Hello, my name is Lindsay Clemens, and we're going to be talking today about Atorvastatin, or Lipitor, the brand name. So, why do we have a need for atorvastatin? So, atorvastatin is a drug that lowers blood cholesterol. And so, around 95 million US adults aged 20 years old and older have total cholesterol levels higher than 200 milligrams per deciliter. Now, the average total cholesterol level that you want to have to be healthy is 130 milligrams. And so 200 is about twice as much. And so that is quite a few people that have twice as much cholesterol as they need. So levels of high LDL cholesterol in particular is linked to increased cardiovascular disease risk, which is the leading cause of death in the US. Now, what is LDL cholesterol? So LDL stands for low density lipoprotein. And this is just a type of lipoprotein that we have in our body. We have 5 different kinds, but the two that you are most familiar with would be LDL, which we associate with bad cholesterol, and then HDL, which we associate with good cholesterol. And HDL stands for high density lipoproteins. But in fact, high density lipoproteins are linked to a decrease in atherosclerosis. And what atherosclerosis is a buildup of plaque in the arteries. And this also contributes to stroke as well as cardiovascular disease. And stroke is the 5th leading cause of death in the US. So we want basically low levels of LDL and higher levels of HDL if we can get them there. So atorvastatin, what it does is it lowers the levels of LDL cholesterol and triglycerides in the blood. And triglycerides also contribute to a thickening of arterial walls, which can also lead to atherosclerosis as well. So, what is the cause of cardiovascular disease when it's cholesterol based? So, in the beginning, we have our endothelial cells in the arterial wall, and these have been stressed. Mostly, they're going to be in the curves of the arteries because those are where you get the most stress, mechanical stress. And so then when it's stressed like that, LDL is recruited and is put underneath. It's subendodermal in the cells. And then what happens after that, these lipoproteins have been retained here. What happens is that the lipoproteins are modified by oxidation, glycation, or enzymatically, and then this activates the endothelial cells. So after that, you have increased expression of the monocytes here. And so then this leads to the attachment transmigration of the monocytes. Monocytes then become macrophages. They differentiate into macrophages. The macrophages then uptake the lipids that have been aggregated in here. And then from there, they become foam cells. And so these foam cells are basically what the plaque is for atherosclerosis. And so this is the initiation of forming that plaque. And actually, once you have these foam cells, the inflammatory signaling pathway is activated, and this leads to more cell recruitment and LDL modification. And so it's kind of a positive feedback loop in that way. So how does atorvastatin help exactly? So what atorvastatin is a competitive inhibitor of the HMG-CoAce reductase. So what does that mean? So when you have the cholesterol pathway, you're going from acetyl-CoA here, and then you're going all the way to cholesterol, and that's more than 20 different individual steps. So what atorvastatin does is it inhibits this step right here. It inhibits the reductase. And so this is actually the rate-limiting step in this pathway. And you can either call it the mevalonate pathway, or you could say it's the cholesterol pathway. So this pathway synthesizes more than just cholesterol. So it's good that it's not a complete inhibitor, but what atorvastatin also does is, even though you would think it's inhibiting the cholesterol at the end, it's doing that, but actually more importantly, it's increasing the number of LDL receptors in hepatocytes in the liver. And what those do are they just uptake the LDL from your blood, and so that also decreases the amount of cholesterol in your blood because you're not producing as much cholesterol and you're taking away cholesterol. And what atorvastatin also does is it slightly decreases the triglycerides, which, as we said before, contribute to atherosclerosis as well, and it increases the HDL levels, which also helps to decrease atherosclerosis. So what exactly is important in this molecule? So we have right here the HMG-CoA, which our drug is trying to act like to get into the enzyme. And so this part right here has HMG-like moiety, and this is what you need. This is what all statins have. And so this is a very important part of the molecule. So here is another small part of the molecule. This is an isopropyl group, which has hydrophobic binding. And then we have our central ring, which is a pearl in this instance for this statin. It doesn't really have any binding importance. It's just important to keep everything at the distance that you need it. And then over here we have our fluorophenyl group, and the fluorophenyl group interacts with the arginine 590 residue in the binding site. And so for differences between other statins and this statin, we have an extra hydrogen bonding site right over here with our serine 565 residue. And so if we can look over here, here is a model of what the binding site looks like in the reductase. And so here we have our fluorophenyl group binding to our arginine. We have our amide group here binding to our serine, our isopropyl hydrogen bonding and hydrophobic interactions over here. And then we have our HMG-like moiety right over here.